This time we have here sequence of numbers, and we are to generate the exponential generating function for both of this. Again, we are on exponential generating function. The form for that is different from ordinary generating function. So hence here, let us try to illustrate this form. But of course, for every sequence a sub 0, a sub 1, a sub 2, until a sub, say for example, a sub r, the equivalent sequence for that, or function rather, which is an exponential generating function, is in this manner: a sub 0 plus a sub 1 x over 1 factorial plus a sub 2 x squared over 2 factorial plus a sub 3, let me place the plus here, okay, a sub 3 x cubed over 3 factorial until we reach a sub r and x to the power of r over r factorial. So with that, now we have here 1, 1, 1, 1, and so on and so forth. Take note that there were no indications that the next would be zeros, zeros, zeros. If you have this form, we are expecting that the rest of the items here, of course, equal to 1 as well. So we have our given exponential generating function. So our f of x here is equivalent to a sub 0 is 1, plus your a sub 1 is also 1 times x over 1 factorial. Then a sub 2 is also 1 times x squared over 1 factorial. 2 factorial rather. 2 factorial. My bad. That's 2 factorial. Then we have plus 1 times x cubed over 3 factorial. As we move also to the rth term, you have here plus plus your rth term here is expected to also have 1. Then you have here x power of r over r factorial. So let me try to separate this later. Okay, we will have that later at the bottom to illustrate the first item fully. So with this now, it's actually equivalent to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus so on and so forth plus x to the power of r over r factorial here, and so on and so forth as well. Okay, if we're going to consider this, let's also consider the sequence that doesn't end as well. Okay, now how do we simplify this into a power series? Take note that let's not in the meantime simplify the factorials here, because this is our rth term. Hence we can actually have here our power series equivalent to just this term. You will have x to the power of r over r factorial as r starts from 0 to positive infinity. And this is actually an important identity for this topic, as this is equivalent to e to the power of x. This is the notation that indicates the simpler form of this when we have our sequence of numbers all equal to 1, so on and so forth. So take note of this. It is also very important as we move further to the deeper topics on this concept, the exponential generating function. Now let's proceed to our second item. Second item has 0 factorial, 1 factorial, 2 factorial, 3 factorial, until you have r factorial, and so on and so forth. So using this formula, so you will have here, function f of x is equal to our a sub 0 is 0 factorial plus a sub 1 is 1 factorial x to the power of 1 over 1 factorial plus our a sub 2 is 2 factorial x squared over 2 factorial plus our fourth rather is 3 factorial x to the power of 3 over 3 factorial plus so on and so forth as we reach with the rth term in our sequence, r factorial times x to the power of r over r factorial plus so on and so forth. If you can see, this is actually equal to 1, the first one, okay, and you can actually cancel all of this as we have the terms in there between. So we will have here a simpler form equal to simply plus x squared plus x cubed, and you have here plus plus x to the power of r plus so on and so forth. This would be our function. Now what would this be equivalent to? Take note, we have this in ordinary generating functions. In this specific pattern, can be written into a rational expression expressed as 1 over 1 minus x. So this is the connection between the exponential function, given with this sequence, exponential generating function, and the ordinary generating function here, because at this rth term, our rth term, you can actually have r factorial x to the power of r over r factorial. This stands for all the summations you're going to do for r equal to 0 to positive infinity. That means in this form alone, you cancel that. Again, this is summation of x to the power of r, or r starts from 0 to positive infinity, equivalent again to this form. So this is the, in short, the only factor for exponential function and the ordinary function is the presence of r factorial. And if we're going to multiply all terms by r factorial, that returns to this given ordinary generating function. So we'll have two more examples for this in generating exponential generating function for a sequence of numbers. Thank you very much for watching.